Alright, in today's video we're going to talk about how to divide polynomials by binomials. So first thing, we're going to factor the numerator and the denominator, if possible. Sometimes the denominator can't be factored. Then we're going to cancel out factors that are common to the numerator and the denominator. Remember, the grouping symbols matter, so the parentheses matter. And then last, we're going to report our answer. So let's look at number 1. First thing I'm going to do is I'm going to rewrite this in fraction form. So I have v squared plus 10v plus 24, all divided by v plus 6. And I'm going to put v plus 6 in parentheses to remind me that that factor sticks together. The v and the 6 are one entity. Can't split them up. Alright, my next step is I'm going to factor the numerator. My leading coefficient is a 1, so I need factors of 24 that add up to 10. And those are pretty simple to identify, 6 and 4. So I'm going to rewrite my numerator in factored form. So I have v plus 6 times v plus 4 all over v plus 6. I'm going to cancel out these groups factors, v plus 6, leaving my final answer as v plus 4. Okay, example number 2. If I look at this particular problem, I'm going to write it in fraction form first. So I have 18n squared minus 57n plus 9, all divided by 6n minus 1. First thing I notice is that my numerator has a GCF of 3. So 3 is a factor of all these different numbers. So factor out my 3, I'm left with 6n squared minus 19n plus 3 all over 6n minus 1. And I'm going to go ahead and put that together to remind myself that it's a group. Next thing I need to do is I need to factor this trinomial here, 6n squared minus 19n plus 3. Leading coefficient is not a 1, it's a 6. So I'm going to take the product of a and c. 6 times 3 is 18. So I need factors of 18 that add up to be negative 19. Again, these are pretty simple to identify. I'm going to need a negative 19 and a negative 1. Or sorry, negative 18 and negative 1. So rewrite this so I can factor by grouping. It gives me 6n squared minus 18n minus n plus 3. Group together my first two pieces, first two terms, 6n squared minus 18n minus n minus 3. So remember, minus and negative is the same as the plus. So think reverse distributive property there. Then I'm going to find the GCF here, which is going to be 6n, and I'm left with n minus 3. GCF here is 1. So my two factors are going to be 6n minus 1 from my outside, two GCFs, and then n minus 3 from my shared factor. So this is equal to 3 times 6n minus 1 times n minus 3 all over 6n minus 1. The 6n minus 1's cancel, so that means my final answer is going to be 3 times n minus 3. And there's the quotient right there. All right, example number 3, getting even more complicated here. So first thing I'm going to do is I'm going to go ahead and write this in fraction form. 30x squared minus 64x plus 32 all over 6x minus 8. Notice that I have a GCF in both the numerator and the denominator. So I'm going to factor out a 2, which leaves me with 15x squared minus 32x plus 16 over, factor out a 2, and I'm left with 3x minus 8. Then I need to factor this trinomial right here. So leading coefficient is a 15. I need factors of 15 times 16, which I believe is 120. Let me just double check that. Yep, oh sorry, it's 240. So I need factors of 240 that add up to be negative 32. So I'm going to start with negative 24 and negative 10. Add those together, I get negative 34. That's not what I needed, so those two don't work. Let's try negative 12 and 240 divided by 12 gives me 20. And those two do add up to be negative 32. So I'm going to rewrite this for factoring by grouping as 15x squared minus 12x minus 20x plus 16. Group my first two terms, 15x squared minus 12x, minus, group my second two terms, 20x minus 16. One more time, minus a negative is a positive, reverse distributive property. Factor out the GCF here is going to be a 3x. So I'm left with 5x minus 4. Minus, factor out my GCF here is going to be 4, which is 5x minus 4. So then I can go back and plug this in. So I have 2 times 3x minus 4 from the factor the GCFs times 5x minus 4, which is the shared factor, all over 2 times 3x minus 8. And here I'm going to go ahead and factor out the 2's. We'll cancel. And I just want to double check and make sure I didn't do anything else wrong here. 3x. Did I copy something wrong? Oh, all the way back here. When I factored out that GCF, that should be a 4. Include in there because one of my binomial factors didn't actually cancel. So now I can cancel this factor, and that means my final answer is going to be 5x minus 4. All right, last example for today. First thing I notice is there is a GCF in the numerator and a GCF in the denominator. So if I factor out the GCF in the numerator, I have 2x squared minus 16. If I factor out the GCF in the denominator, and I have 2x plus 4. This is the difference of squares, so I can factor that relatively quickly. It's going to be x minus 4 times x plus 4, all over 2 times x plus 4. Cancel the shared factors. And that means my final answer is x minus 4. Short and sweet.